Good morning, everyone. Welcome to this beautiful Saturday morning. Hopefully it's beautiful where you are as well. Um, at this time today, I'll be presenting a presentation on data to dashboard, as you can see in front of you. This particular presentation is connected to our HackHPC at ADMI Hackathon, which, if you can believe it, will be starting this coming Thursday with our kickoff and draft. Yes, ma'am. So we have a good week coming up, and I believe this will work very well. Again, I want to thank you so much for being here on a Saturday morning. You're giving your time on a Saturday morning to be with us. Now I'm going to take this up here. I believe you're seeing just a little bit of a gray out, and I want to hide my floating meeting. No, I don't want to hide it. I want to move this. Okay. All right. So we're going to leave that alone then in this case. So moving on. Now, in the chat window, I dropped a couple links. I will reapply them a little bit later as we go through. But please feel free to reshare those of you that were here early to see them. So that you can play along at home, so to speak. Now, today I'm going to do a couple of introductions, and I'm going to go over the hackathon objective, our deliverables and resources, some general information, but then we're going to get into the good stuff, the meat that you have come here to find out about. When we go into our stages of dashboard, our developmental cycle, and then a quick example as well of a little bit of a Dash app. I also would be remiss not to acknowledge my fellow organizers of HackHPC at ADMI. A few of them are here today. Dr. Linda Hayden, who's also a member of the board there at ADMI. Dr. Hayden, would you mind saying hello for me?
Hello to everyone. Welcome to our hackathon training. We're looking forward to the event itself. ADMI's going beautifully. And so just, get all you can from this training because you'll be putting it to use next week this time.
Yes, ma'am. And also Mr. Boyd Wilson from Omnibon. I see he's on. He's probably also preparing himself for his presentation here, which will be starting shortly after mine. Boyd, would you like to say good morning?
Good morning, everyone.
Hey,
good luck, Tim. You'll do great. So pay attention. Got a lot to teach y'all.
Excellent. Thank you, Boyd. So also we have Amy Cannon from Omnibon. Myself, Jamie Powell. I'm actually part of the Texas Advanced Computing Center, where I'm a senior systems administrator and researcher. Dr. Alex Nolt is also a part of us. And Mr. John Hawley from Exceed. And all of these fine people are basically, we're a family that we invite everyone else to join our family as we put on these different hackathons. Now, the hackathons itself, what we aim to do is to harness those resources and tools and skills and knowledge sets that are found in the high performance computing field and blend them along with students and faculty so that we can provide access and exposure to these different technologies while we're focusing on a problem that is near and dear to our participants. In short, we actually provide HPC skills and training while you're working on problems or directly applying those skill sets to problems that directly affect you. You're going to learn about different solution sets, identified issues, and things like that go along with it as well. Now, it is not specifically affecting St. Louis, but it will be affecting, these are things that can affect you in your local area. You're going to learn some increased familiarity with data science in the cloud, experience some collaborative software engineering for my computer scientists. You know that is a very interesting thing, and develop professional communication skills as well. Now, the student deliverables. and resources. For the students that are here, as well as the mentors, just to remind you, we are kicking off next Thursday, March the 31st at 7 p.m. Eastern, 6 p.m. Central, 4 p.m. Pacific. And then we finish up on Monday, April 4th at 6 p.m. Eastern with our final presentations. Well, during the final presentations, prior to that, we're going to expect that you have sent us a link to your GitHub repository. And I actually did a presentation on how to use GitHub basics yesterday. And that information is on our website that's listed down there at the bottom. But we expect you to send us a link that has a set of your code with comments, of course, because we're computer scientists and we want to make sure that we add comments to our code. A PDF of your final presentation that includes pictures of your team members along with their names, how you use HPC technology in the project, and your readme.markdown file should be edited so that it gives us a little bit of a description of the project that you worked on. I have a list of a few of the resources that are available to you. The big one that you want to pay attention to right now, because you will have the opportunity to use it in, a little bit less than an hour. Cloudy Cluster and Google Cloud. Google is one of our sponsors, and they've kindly provided us with credits that you all will be able to use. And Mr. Boyd Wilson will actually be giving that presentation, as I said, fairly shortly. Python, some of the commonly used software include Python, Jupyter Notebooks, Node.js, Replit, which is amazing if you're a programmer, so that multiple programmers can work together on a project, as well as, of course, HTML, JavaScript, some of the tools that you are very accustomed to using. And we also have our Discord. If you have not joined our Discord, please do, especially our mentors and our students, so that that's where we provide our information. Now, having said that, general information, the 3 T's. Our teams will have 45 students, 1 primary or faculty mentor, and then 1 technical mentor with these teams. The teams are comprised of your schools. There's a dashboard that I show every once in a while to kind of show what's going on, but to keep it short, there are about 13 individual schools. The majority of those schools have their teams preformed. There are a few that we're going to squeeze together, but those teams are preformed and you're going to be a part of the draft. It starts on March 31st, goes through April 4th, with our kickoff on Thursday that I've spoken about with the draft, which I talk about in one of our previous, Mr. John Holly will be hosting that, one of our previous presentations. He's actually spoken about that actually in the GitHub and Discord video. So of course you can take a look at that on our website. But after that, Friday, Saturday, and Sunday, there will be check-ins. And these check-ins are ensure that, number 1, your team isn't having any issues, that you all are still making great progress. And number 2, we're going to have a few surprises that go on during those events that we, well, for those of you that have been a part of our hackathons before, don't spoil it for others. And then finally, we have our final presentations. Some of the topic examples include COVID-19, economic disparities, social justice, gerrymandering, graduation rates, broadband access, and the list goes on and on and on, depending upon what projects the mentors bring and some students. So now, the reason you have come. The name of this presentation is Data to Dashboard. Now, I have grown up when I give presentations, I'd like to ensure that we are all on the same playing field, on an even base when we start. And so we need to make sure that we're using our vocabulary the same way. And so I, being a good host, wanted to find a good definition of data. Now, people that know me know that I have a tendency to grab onto things like a bone and just chase after them. And the definition of data ended up being one of those things. There's a thing called an overloaded term, What that means is there's a term that, depending upon where you are in the world, what particular section you're a part of or specialization you're in, that term can have multiple meanings. So for example, if you're a programmer, a software engineer, and you hear that on the third floor, there are people coding all over the place. It makes you extremely excited. You're like, they're working hard. That is great. But if you're a doctor and you hear somebody say there are a bunch of people coding on the third floor, you're a little concerned. Different definitions. It's called an overloaded term. So I tried to find this simple definition. And this is what I came up with from good old Merriam's dictionary. Factual information such as measurements or statistics used as a basis for reasoning, discussion, or calculation. Information in digital form, information output by sensing device. And it didn't really feel great to me. And so I started digging a little bit deeper, and I wanted to look at it in terms of this presentation. And so I started looking for examples of data. And you see a couple of those examples there. We have everything from CSVs with weather data. We have some information with shape files for setting up georeferenced information. We have text concordances if there's somebody's doing text sentimentality. We have information from tweets determining sentiment of people's tweets. We have sound files and examples there. We have pictures depending upon, and so what I decided to coin my own definition. And what I decided to say is that in the context of this presentation, data is information that you want to collect in a digital format for the purpose of analysis. Let me give myself a pat on the back for that one. I made it easy. No smiles. It's Saturday. Nobody. Oh, okay. That's fine. I was proud of it.
Yeah.
I even put the little tilde there. I was proud of that one. So then we need the second part of our title, dashboards. If I were you, I'd be scared to ask, what is a dashboard? Thank goodness this is an easy one. Dashboards basically are some type of visual format that frames a problem or question that in a way that tells the story using your data. And so we have an example here. And this example actually comes from our participants here in the hackathon. Our problem as organizers was we needed to know who was registering for the hackathon. And so I framed it with this dashboard that you're looking at that I made using Google's Data Studio, imported as a data source, or where the data comes from Google Sheets. And then I was able to display these different characteristics, these different variables, so that it tells the story. It tells the story that we have about 60 registrants at the time of this. There were about 12 schools that are participating. We can see how many come from each school. We can see the mentors and staff, the different majors that are joining, the gender registrations, the registrations by role. We can see that we have almost an even split between the different classifications of students, junior, freshman, and sophomore for undergraduates. All these things help tell the story of the data that you all provided when you registered for our hackathon. It's pretty interesting. So now, how do we do it? Well, I'm gonna warn you ahead of time. Creating a dashboard is a bit of a process. It's a developmental process. And we're going to go into these 5 different sections little by little. There are a couple I am going to target with a laser beam because a lot of the teams, when they're creating these different projects, they may get stuck or hung on some of these sections. And so I want to make sure we dig into them. And then in our example, in our demo, I'm going to go through the demo through the lens of this developmental process so you can see how it works. Now, again, I am going to say out loud that if you have any questions, please feel free to stop me and ask. You can, of course, I keep looking over. When you see me look this way, I'm looking at you, and I'm also looking at the chat box. I'm going to add back in here our example GitHub repo, as well as the example application that's going to come up a little bit later. I'm adding it now, just in case I get caught up and forget to put it there, but there we go. So let's dig into this. Whoop. Let's dig into the right slide. There we go. So our first part of our developmental process, dashboard development process, is the design itself. And these are where you ask those 5 W questions that we've all grown up with. But they are essential. Before you dig into creating this product, you need to understand what a product's about. You need to understand who your audience is. For instance, with the dashboard that you saw a moment ago for ADMI, I knew that my audience were the mentors and organizers for the hackathon. We need to define what the question is. And that sounds simple, but it's not sometimes. Especially when you're starting a hackathon, a lot of times the project ideas are very grandiose. They're very grand or broad. And you have to squeeze that down into an answerable question. And sometimes that takes a little time. Oftentimes when I'm working with my coworkers and we're actually designing dashboards, we do this entire section, this dashboard design. We are sitting in the real world, we'll be sitting inside of a conference room and writing these up on the whiteboard. If I'm doing them personally, I'll take a sheet of paper and just draw it out, including a pen and paper mock-up. And you're actually going to see that during our example. You're going to want to understand where your data is coming from, what website in general, and what platform you want this to be hosted on. For instance, for the example you're going to see today, it's a mixture of GitHub and Heroku. And then the outputs from this include our site mockup, clearly defined question, the platforms to be used, and the type of data you need for analysis. I didn't say find the data, but the type of data that you need for your analysis. And then we come to actually collecting that data. Now I want to note here, I put it in red, bold, so you can't miss it, that this is about the 3rd most time-consuming process that you're going to have, is collecting the data. And the reason for that is that you have to actually locate your data sets. Now, fortunately, we have technical mentors, faculty mentors that once you shape your problem, they have found data sets their entire career. They may have access to data sets. We actually provide you a list of data sets as well on our website to assist you. But finding the data you need can sometimes be painful. And so sometimes you have to ask, from our previous question, what question do you want to ask of the data? You might dig in, especially with health questions, and find out you don't have exactly what you need. And so then you shift over to what questions you can answer from the available data you have. And what we mean by that is sometimes you have to reshape your idea or rephrase your question as far as in looking at the available data and answer your question in an indirect way. Now, off the top of my head, an example would be something similar to, let's say there's a health condition that persons have. Let's say you want to check for the number of smokers in the area, for instance. And with health data, a lot of times with HIPAA regulations and whatnot, that specific data may not be available, but you do have access to lung information. And so you can write a descriptive indirect correlation between lung disease versus smoking, or lung cancer specifically versus smoking. See, so that you're using those indirect correlations. So your outputs from this, again, just to say them specifically, data sets, data dictionaries. Data dictionaries are basically information that you write down or sometimes script up that or code to say that this data set, this line of data, this column of data means this other thing. It's called a data dictionary. Sometimes they're very useful. Suggested analysis, correlation methods, documentation on the data set, as well as an important one for someone like me that's in IT/IS. Where are you going to save the data? Where is it going to be located? Which brings us to the most time-consuming process whenever you're dealing with data, and it's called data piping or data cleaning. I've heard other people call it tidying up your data and or data carpentry. All of these things mean the same thing. And what it means is the data you receive is quite often not in the form that you need it. And it can be painful to transform that data to become what we call tidy data, wherein you can actually use it in the method that you need. This can be very, very time consuming. I don't want to fake the funk on this. I don't want to sugarcoat it. It can take time. Some of the tools that people often use include Python, R. Inside of a Jupyter notebook, they're constantly taking a look at it to see how the data is moving and changing and operating to make it correct. Some people use Excel spreadsheets or Excel or Google Sheets if the data set is small enough. But the point is, prepare yourself to take time. For some of the other mentors that have been a part of projects, especially these hackathon projects, generally speaking, Saturday becomes fix the day-to-day. From what I have noticed at the hackathons, it becomes fix it. It is what it is. During this time, you're going to clean your data set using scripts generally, so you can make transformations to turn the unusable data into usable data. If you do not do this, a lot of times the analysis that you perform on the data sets will be invalid. So here's an example from the ADMI dashboard that you saw earlier. On our form, you as students and mentors are allowed to type in your school name any way you want. So most obvious one that is sometimes difficult to deal with are spelling errors. It happens, like you have your finger slips, you hit the wrong character, there's a little swap. It can happen. The next one, different capitalizations. So Elizabeth City State University, some people may type it in all caps. Some people may type ECSU. Some people may have a capital Elizabeth, a lowercase state, and it goes on and on and on. Well, each one of those, when you sort it, the capitalization matters. And so it looks as those as different entities, each one of those. Part of the transformation for the data set, I had to go through and make sure it was all the same. Winston-Salem State, some people put the dash in, some people didn't. Mississippi State, some people missed the, MI cricket letter. That was just one cricket letter I, humpback I. Yep. Anyway, those are some of the issues that can occur. So again, most time consuming, please be aware. Although I hit on this, I just want to dig in a little bit deeper. There's this idea, this concept of garbage in, garbage out. In other words, if you bring in a data set that is messed up, just like I was just talking about with the different school names, that was just one example, your results of your analysis will likely not make sense. We have 60 different schools registered. No, we don't. It's just everyone typed their school name differently. We need to validate them, organize them, make sure they're working the way they're supposed to. One of the other issues, repeating headers. In other words, that top row where you're saying what each data set it is, you have one that says date and the other one says date. Which date is date? Well, this is the date I filled out the form versus the date I plan to be at the hackathon. And so you need to correcting those issues in the headers. Sometimes there are full sentences in the headers that have to be adjusted down to something smaller and abbreviated. And again, this can be a part of your data dictionary to fix things like that. And when you're selecting your database, If you're doing something with GIS, so geoinformation systems, or something where you're making a geo-rectified map or a chloroplast map, you may need a geo-reference enabled database. So you might use Postgres, but you might want to make sure you add on that PostGIS extension to the database. In the case of using pandas for my Python people, you may want to use GeoPandas instead so that it understands GPS coordinates and whatnot. It's a small difference that in making these changes and making these decisions with your data will make your life a lot easier. But again, just a reminder, it's the most time-consuming process. I'm also very proud that I was able to get Oscar the Grouch in here. Thank you for joining us, Oscar. One last thing, tidy data. You've heard me use this term, tidy data. All that means is that each variable is a column, first name, last name, address, email address, longitude, latitude, column. Each observation is a row. Jenny, Jamie, Linda, Amy, Boyd, Rose. And each cell is a value. This first name is Boyd in this row, in this one cell. Each value is a cell. I know this sounds simple, but sometimes your data sets will be all over the place. You will notice this when you're working. Again, that's why I keep pushing. This is the most time-consuming part of this developmental process. Getting it to this tidy method sometimes can take a little time. So just a forewarning, just a forewarning. All right. So now we're going to go into building an actual dashboard. Now, this is the second most time-consuming process, not because it's difficult. A lot of times this is the fun part because you're actually working with code and you can see what's going on, but because we as programmers and designers sometimes nitpick until we get it exactly the way we want to, and that can take a little time. Not as much time as getting the data ready for it, but it does take a little bit of time. And sometimes we are learning new things. I want to say out loud that one of the most important parts of once we make our mock-up is picking the correct chart type. We have some references in our presentation here that of course I'll make available to you later. It's on one of the later slides for a couple of sites that will actually help you pick the correct type of chart. For instance, I used a term earlier, chloroplast, a chloroplast chart. Well, a chloroplast chart is a chart that has states, counties, or countries that you can, inside your data, if you're selecting that or it has that particular item, you can actually make that area change to a different color. It's something that we've seen before, but the name of that chart is a chloroplast chart. I didn't know that. And so having the sites that will actually show you that information, so when you're making your mock-ups, as well as when you're building a dashboard, helps. So during this process, of course, you're going to have your data pipes and sources. You're going to decide on you're going to actually implement your filters and sorts and selection modes and add your elements and lay them out on the page. But the output of this section is the fun part. You have your code that you actually use to build it, as well as a deployed, usually deployed either locally or publicly version of your dashboard. I love this part. You have to come back to it a few times though, because then we get feedback and testing. Now, I left up here most time-consuming process because I didn't mean to. It is a very repetitive process though. Feedback and testing, you have to do over and over and over again. It starts the entire process over again. You want to make sure that any issues you have, you want to address, you set them as tasks, you decide who is going to take care of that task, you work on it, you ask yourself, did the dashboard actually answer the question we set out to? Yes, no, I don't like the colors you're using. That has happened. That has happened before. And you change all these things, going back through the design, collection, clean, build, test, until you get it to a point that you're happy with it. And it's an iterative process. You keep doing it until it's done. Now, don't get me wrong. Sometimes it can be a never-ending story. But there is a point at which you have to say, enough is enough, and stop. But I do want you to know this is a process that just keeps on going until you get it where you need it. All right. So we now know the process. Let's get dangerous. We're going to go into an example. Now, I do want everyone to know that outside of this slide, the rest of the slides, wherever I've mentioned the GitHub repo or Heroku or a specific file inside of the repo, I have QR codes listed so that you can use your phone to go to them and take a look at them. They are also listed inside the chat box. Feel free to use those. I am going to drop them in there one more time. So let me copy this. So first I'm going to copy the GitHub link and drop that in here. And then I am going to copy the app as well. And this time I'll try to grab the beginning of the E and drop that in. There we go. All right, here we go. So dashboard design, remember, this is the section where we come out with our question. We come out with some brief documentation about how we want to address it. We have our drawing of our mock-up, and that's exactly what you see here. In the case of this, the question was, they wanted a dashboard to link Texas residents with the information for their US congressional district. Texas is huge. It is a massive state. If anyone has ever driven through Texas, generally speaking, if you are driving through Texas, there is a solid day of driving through nothing but Texas. I live in Texas. I live in Austin, Texas. I am in Central Texas. So it takes me a day to get outside of Texas before I can go to other states. We have a lot of congressional districts because we have a lot of people as well. And so this is a viable tool. We want to make sure that there's a map that you can click on the map and it will show you the congressional district from the texas.gov site. And again, like I said, you have the actual mock-up there. So this is an example of the outputs. Collecting the data. Now remember, this is the third most time-consuming process. In this case, we had to go to the capital of Texas.gov site. We had to find the actual districts. It was a dig down process to find exactly what we needed. And then we had to figure out how their API, their application programming interface, worked so that we could pull the appropriate PDF. And you can kind of see that listed here up at the top. So if we wanted district number 20, we need to go to WRM, capital text.gov, FYI, web docs, PDF, Congress, dist 20, and then map 1. So that dist 20 had to change. And so we had to account for that in our code. Then we had to clean the code up. So like I said, we wanted that dist 20. We had to write code in order to make sure we could pull the one that we wanted. So you can see the district map prefix, the beginning, WRM, capital Texas Gov, FYI, web docs, PDF, Congress, and then our district map link. And then we had to select which district we wanted by clicking on it and make sure that we got the correct output. Again, I have we did this in Jupyter Notebooks. The link to it is there. The QR link is there. That is a part of the GitHub. So you can kind of get an idea of what that whole data piping and cleaning is. In our case, we wanted to use GeoPandas because that makes sure that the information we're pulling is geo-referenced. We're using a visual map that when we click on, we get a GPS coordinate. GPS coordinate says it's in this district, if it's in this district, or in this county. If it's in this county, it's part of that district. Then we got to do the fun part. The second most time-consuming process, building the dashboard. Now, we used an application in Python called Dash. And again, we'll have some references to this after. what Dash allows you to do is to build in the app layout section, to build the app much like a web page. And you'll actually see that over here in the app layout window. So you'll see things like your div and your rows and whatnot. So it makes it very straightforward if you have an understanding of JavaScript / HTML on how to build your site. And then in the callback sections, it's where you actually do your work. That's where you have what happens when you click, what your chart actually displays and where it's displaying to. There are tons of tutorials on this online. I highly recommend that if you are in charge of doing any type of dashboard like this, that you go out and take a look at a few of them. But there are so many available out there. I'll waste your time going into it. And then we went back into feedback and testing. And so what we had here is we used a service called Heroku, which is free, that connects to GitHub. And again, that information is provided. It's a very seamless transition from a GitHub repository into a Heroku application that presents this application where we can click on a congressional district. In this case, I clicked on District 17, and it actually showed the map. But let's prove this works. So this is demo time. So I'm going to go ahead and I'm going to hit escape. I'm going to go into that very app. Now, I cheated just a little bit. I went to this site before you got here because Heroku is free. The way they keep it free is they have containers that they spin up as they're needed. And so sometimes it can take a minute or two for it to come up. So I did cheat a little bit. So we have our map here. We have our different of Texas. We have our different congressional districts. And so if I wanted to click close to our district, I can zoom in here. And let's say I want to click right here on Congressional District 35. And indeed, when I click on it, it reaches out to that Texas site, that redistricting.capital.texas.gov, and pulls the PDF for Congressional District 35. So it indeed does accomplish the task that we wanted it to accomplish. So see how all that comes together? All right, so going back into our slideshow. Listed in the presentation are, of course, a list of all of these various resources that are available to you. Of course, you can grab a screenshot of this, but this will be posted on our HackHPC website as well for your viewing and your use pleasure. Just because I also want to throw out there, just because I use Python doesn't mean you can't use R. Just because you use R doesn't mean you can't use some other application that you think will be easier for you. The power of IT and IS to me is the fact that there are many different ways to do every task. The big goal is to accomplish your goal, to answer the question, to do the project. A lot of times it doesn't matter how you do it, it's the output that you get. Now, I will say in the case of the hackathon, we do want you to use HPC technologies. And we of course are giving you a few, and it is a time that you can stretch yourself while having that backup of people that can assist you. So, having said that, that is actually the end of my presentation. Now, I want to make sure I put out there that this is not the next session, which is Google and the Clouded Cluster. Will actually be hosted here at, is it 10:25, Boyd?
Boyd is never. Yeah. Yes.
Okay.
Yes.
All right. So at 10:25 Eastern, 9:25 Central, which means that in about 10 minutes from now, Boyd Wilson will actually be going over Google Cloud and Clouded Cluster. I highly recommend you attend that session. And it is a hands-on session, I believe. So I will put that out there. But at the same
yes, it's.
Oh, it is excellent.
It is hands-on. So,
Ooh.
and everybody gets to have their own quick labs session for Google Cloud. Google set that all up, and we've tested a few times this week. So knock on wood, it should go smoothly.
Excellent.
I see it listed on the agenda as 11:15 a.m. to 1.
Oh, 11:15. Okay. Oh, good.
Well, and that's why, Jamie, I thought you were talking your time zone versus my time zone. Then you said Eastern. So anyway, yes, it is.
11:15 to 1 Eastern.
Yeah, you get a break.
Not a problem. So just to put that in perspective here, so I'm first, before I say this, I'm going to go ahead and copy this link, and this is the event site. Paste that in chat. So this is the event site for the hackathon, and I can go to our schedule right here. And we do have our the cloudy cluster at 11:15 Eastern. So you're absolutely correct. 10:15 Central, which is the time zone I'm in. For those that are here, one more time, just to put out there that then our kickoff will take place next Thursday, March 31st, with our draft. And we will move very quickly until we get to Monday, April 4th. Now, on April 4th, for those of you that are not a part of the hackathon, I am so gracious that you have joined for this particular session, and I appreciate you coming. If you would like to view the final presentations and award ceremony, the stream will be listed here next week, so that you can actually join it when the time comes. So we welcome you to come and to see what our students and mentors have created in this very short period of time. And for my mentors and students that are and staff members that are a part of this great journey, this is what you have ahead of you. And it's going to be fun. It's going to be a fun, good time. Now, and I'll go back to the main site. So all of our prior events will be listed here. So as you can see, GitHub and Discord trainings here. The training that I'm doing right now will be there shortly. Of course, it takes YouTube a little while to process the videos as well as me to post them. But all of those that have been previously listed are there, along with the slide decks that go with them. So please feel free to stop in and take a look at that. Now, having said that, I'm gonna hit stop share. I want to take a look at everyone that's here. And if you wouldn't mind, I want to ask a favor. I know we've lost a couple, no, actually we've gained more. Oh, wow. If you all wouldn't mind, for my records to prove to my job that I was actually here, would you mind turning on your camera so we can take a picture, please? If you're able to, if you wouldn't mind turning on your cameras for a split second and say hello. There's Dr. Humphreys and Chutma and Raymond and I'm going to say Alfred, Al, and Boyd and Dr. Doswell. Thank you so much. Oh, there we go. There he is. Thank you, sir. Thank you, Kevin. Sam's coming from the car. That is commitment. Thank you, sir. I appreciate that. All right. Now what I need, and then he turned it off. See, that's just wrong, Sam. That's wrong. I gave you like valuable.
Sam.
There we go.
Yana, Amy.
So there we go.
Denisha. Come on, Barry. Martin.
Now what I need you all to do, if you wouldn't mind, I want you to stare intently into your camera. Because remember, my camera's here, not there. It is here, not there. And I want you to give us a smile. And I'm gonna go 1, 2, 3. All right, we're gonna do that again because my face looked like 2. So we're gonna go ahead and hit 5. Are you ready? 1, 2, 3. All right, thank you all so much for coming. I'm gonna stop the recording now and answer any questions you may have. Thank you so much for turning on your cameras. I know it's a Saturday. Thank you so much.